Finite Math, Exponential Functions. In this video, we're going to define an exponential function, find the correct exponential function graph, and then solve exponential equations. As you go through this video, you're going to see some icons on the top left. This icon tells us we're going to talk about the process, some examples, you get to practice, a little self-quiz, and then finally what you need to do to get good at it. Remember, it's not magic, it's math. So let's get started. Basic properties of the graph. F of x equals b to the x when b is greater than 0 and b does not equal 1. Number 1, all graphs will pass through 0, 1. 2, all graphs are continuous curves with no holes or jumps. 3, the x-axis is a horizontal asymptote. 4, if b is greater than 1, then b to the x increases as x increases. That means as the y value increases, the x value increases. And 5, if 0 is less than b is less than 1, then b to the x decreases as x increases. That means the y value decreases as the x value increases. For some of you, some words may be new. For instance, all graphs are continuous curves. That means that when we draw the curve, we do not lift our pencil. The x-axis is a horizontal asymptote. Well, horizontal asymptote means that our graph will never pass the x-axis. For this class, exponential functions will not have negative bases, but if the base is negative, exponential functions will be complex functions. Let's look at a graph of an exponential function. On the left side, we have the graph f of x equals b to the x, where b is greater than 1. That means that b is a positive number. On the right side, we have f of x equals b to the x again, but this time b is between 0 and 1. That means that b is a decimal or a fraction. You're going to notice that when b is positive, it goes up to the right. And when b is a fraction, it goes up to the left. Let's review our properties again. Let's look at number 4. If b is greater than 1, then b to the x increases as x increases. So that means that as my x value increases, you're going to notice that my y value increases. Number 5 says, if 0 is less than b is less than 1, then b to the x decreases as x increases. This gets to be a little hard to see. You're going to notice as our x increases, our y decreases. For exponential functions, sometimes we have to compare the functions. Let's look at the left. When b is greater than 1, we will have an ordered pair at 1b. Basically, a larger base is closer to the y-axis. Another thing to remember is that all of our graphs will pass through 0, 1. If I have y equals 2 to the x, that means that 1, 2 is going to be on my graph, and that's right here. So that means that this green is y equals 2 to the x. Y equals 4 to the x, that means that I'm going to have an ordered pair at 1, 4, and that's right here. And then we have y equals 9 to the x. That means that we'll have an ordered pair at 1, 9, which is somewhere up here. That's one way we can compare when we have b is greater than 1. Also, a larger base is closer to the y-axis. What do I mean by that? Well, I have a 9, a 4, and a 2. Which one is larger? Well, 9 is larger, so the graph is going to be closer to the y-axis. If I compare 4 and 2, which is larger? Well, 4 is. So 4 is going to be closer to the y-axis, and so on. Now when we get over to 0 is less than b is less than 1, we still have an ordered pair at 1b. A smaller base is closer to the y-axis. Now this gets to be a little much, so I'm going to try to zoom in here. We have 3 graphs. Y equals 0.2 to the x, y equals 0.5 to the x, and y equals 0.9 to the x. When I look at my graph, I know that 0.2 to the x is going to have an ordered pair at 1, 0.2. That's going to be right here. Then I have y equals 0.5 to the x. That means I'm going to have an ordered pair at 1 at 0.5. Finally, y equals 0.9 to the x means I'm going to have an ordered pair at 1, 0.9. When I look at these, I'm actually looking at my bases. I have 0.2, 0.5, and 0.9. 0.2. I know it's going to be this graph, and if I follow this graph, you're going to notice that it's closest to the y-axis. y equals 0.5 to the x? Well, that's this one, because I have the order pair 1, 0.5. And if I follow this graph, you're going to notice it's right in between 0.2 and 0.9, because 0.5 is between 0.2 and 0.9. And then finally, here's my last order pair. And if I follow that, you'll see that's 0.9 to the x. That's why a smaller base is closer to the y-axis. Pause the video, match the equation to the graph, and then press play to check. Let's see how you did. First, we're going to look at y equals 3 to the x and y equals 10 to the x. Y equals 3 to the x is going to have an ordered pair here at 1, 3. That means B is our graph. Y equals 10 to the x means I'm going to have an ordered pair at 1, 10. That means A is our graph. Remember, a larger base is closer to the y-axis. And that's true for these. Since 10 is larger than 3, the graph y equals 10 to the x is going to be closer to the y-axis than y equals 3 to the x. Let's look at the other two equations. Y equals 3 to the negative x. That's the same as y equals 1/3 to the x and 0.3 bar to the x. Remember, 0.3 bar means 0.33333. Y equals 12 to the negative x means y equals 1/12 x, which is the same as 0.083 bar to the x. Now that means, once again, 0.0833333. When I look at y equals 0.3 bar to the x, I know that my ordered pair on the graph is going to be 1, 0.3. So I put my ordered pair right here. If I follow that graph, I can definitely see that the graph for y equals 3 to the negative x is C. If I'm going to graph y equals 0.083 to the x, my ordered pair is going to be 1, 0.83. And that's going to be a row right here. And if I follow that graph, I can see that that's D. Remember, a larger base is farther from the y-axis. If I compare 0.3 and 0.083, I can definitely see that 0.3 is larger. So that's why I picked C. That graph is farther from the y-axis than 0.083. Here's one for you to try. You're going to pause the video, match each equation with the graph of f, g, h, or k, and the figure, then press play to check. Alright, let's see how you did. Let's look at A and C together. Those both have when B, our base, is greater than 1. B and D are both when we have a base between 0 and 1. 1/6 to the x is the same thing as 0.16 repeating to the x. We're going to look at A and C first. They give us y equals 5 to the x and y equals 9 to the x. Remember, our larger base is closer to the y-axis. So which base is larger, 5 or 9? Well, hopefully you said 9. So that means h is 9. That only gives us that y equals 5 to the x is f. Let's look at B and D. The larger base is farther from the y-axis. I have 0.5 and 0.16. Which is larger, 0.5 or 0.16? That is going to be farther from the y-axis. So hopefully you said B is G, or y equals 0.5 to the x is the farthest out. You're correct. And then D is K. Cool. Graph the following function over the indicated interval. Y equals 2 to the x between -3 and 3. What does this mean between -3 and 3? You're going to notice that each of these graphs only show between -3 and 3. We need to choose the correct graph below. Let's look at A. Does it cross 0, 1? Nope. So it can't be that one. So it can't be that one because all of our exponential functions cross at 0, 1. What about B? Well, an exponential function is not a parabola, so it can't be that. So we need to look at the last two. Look at the exponent. Will the graph go to the left or to the right? If b is greater than 1, then b to the x increases as x increases. And that is C. Graph the following function over the indicated interval. For this one, we have y equals 1/5 to the x, which is the same thing as 0.2 to the x, which is the same thing as 5 to the negative x. Once again, we're graphing on the interval between -3 and 3. Our first one is a parabola, so it can't be that one. Let's look at the next one. Does it cross through 0, 1? It can't be that one because all of our exponential graphs will go through 0, 1. Well, now we have to make a choice. Is it the third one or the fourth one? Look at the exponent. Will the graph go to the left or to the right? If b is between 0 and 1, then b to the x decreases as x increases. Yep, it's going to be 3. Properties of exponential functions. A to the x equals a to the y if and only if x equals y. Let's look at an example. Solve the given equation for x. 9 to the 1 minus 4x equals 9 to the 9x minus 5. Let's look at our formula. Do you notice that the bases are the same? When we look over here at our question, our bases are also the same. That means we can make their exponents equal to each other. Since the bases are the same, we can simply set the exponents equal to each other. And now we're going to solve using algebra. I like to move my x's first. I'm going to subtract 9x from both sides. I want to get -13x by itself. I'm going to subtract 1. So I have -13x equals -6. I want to get x by itself, so I'm going to divide by -13. This gives me x equals 6/13. And yes, you can have a fraction as an answer. Let's look at the next one. Solve the given equation for x. 3 to the 3 minus 3x equals 3 to the 9x minus 3. When I look at these, I need to make sure that my bases are the same, and they are. That means I can make their exponents equal to each other. Now let's solve. I'm going to subtract 9x from both sides. This gives me 3 minus 12x equals -3. I'm going to subtract 3 from both sides to get -12x equals -6. Divide by -12, and I get x equals 1/2. You get to do the next one by yourself. Solve the equation for x. 9 to the 3x plus 4 equals 9 to the -x plus 12. Hopefully the first thing you did was notice that our bases are exactly the same. That means we can make the exponents equal to each other. 3x plus 4 equals -x plus 12. I like to move my x's first, so I'm going to add x to both sides. This gives me 4x plus 4 equals 12. Subtracting 4 from both sides, we get 4x equals 8. Divide by 4, and x equals 2 is our answer. Solve the given equation for x. 8 to the -4x minus x squared equals 8 to the 3. First of all, we need to make sure that our bases are exactly the same, and they are. All we need to do now is make the exponents equal to each other. We have -4x minus x squared equals 3. Anytime we have an x squared, we know we're going to have to factor, and we really like the x squared to be positive. I'm going to add x squared to both sides, and then I'm going to add 4x. That gives us 0 equals x squared plus 4x plus 3. Perfect for us to factor. To factor this one, I have to think of two numbers that multiply to 3 that also add to 4. For this one, 3 times 1 is 3, and 3 plus 1 is 4. This gives me what I like to call my magic numbers. It's going to factor into x plus 3 times x plus 1. Now, we have to take everything with the variable x and make it equal to 0. This gives us x plus 3 equals 0 and x plus 1 equals 0. Let's solve. I'm going to subtract 3 from both sides, and x equals -3. Then, on the next one, I'm going to subtract 1 from both sides, and x equals -1. And that gives us our answer, -1 and -3. You get to try these two by yourself. Pause the video, do them, and then press play, and we'll check them together. Let's look at the first one. 4 to the x squared equals 4 to the -x plus 12. Our bases are 4. That means we could just make their exponents equal to each other. X squared is already positive, so I'm going to add x to both sides and then subtract 12 from both sides. This gives us x squared plus x minus 12 equals 0. Perfect for us to factor. That means we need to think of two numbers that multiply to -12 that also add to 1. 4 times -3 is -12. And 4 plus -3 is 1. That gives me what I like to call my magic numbers. we'll have x plus 4 and then x minus 3. Let's put them into our equation. Now, everything with a variable gets equal to 0. So I'll have x plus 4 equals 0 and x minus 3 equals 0. X plus 4 equals 0, I subtract 4 from both sides, and x equals negative 4. X minus 3 equals 0, I'm going to add 3 to both sides, and x equals 3. That's our two answers. Let's look at the second one. 6 to the 6x minus x squared equals 6 to the 8th. My bases are the same, 6, so all I have to do is make their exponents equal to each other. Now I have an x squared, so I know I have to factor. And we want to factor when we have a positive x squared. So I'm going to add x squared to both sides, and then I'm going to subtract 6x. Now it's in the form that we can factor. We need to think of two numbers that'll multiply to 8 that'll add to negative 6. I know that negative 4 times negative 2 is 8, and negative 4 plus negative 2 is negative 6. That gives us our magic numbers. So we'll have x minus 4 and x minus 2. So let's substitute that into our equation. Everything with a variable gets equal to 0. So I'll have x minus 4 equals 0 and x minus 2 equals 0. X minus 4 equals 0, I'm going to add 4 to both sides, so x equals 4. X minus 2 equals 0, I'm going to add 2 to both sides, and x equals 2. That means x equals 4 and x equals 2 are my two solutions. If you're having problems factoring, I suggest you go back and review. All you need to do is go into YouTube and put factoring. There'll be lots of videos to help you. Here's the self-quiz. You're going to pause the video, complete the questions, then press play to check your answers. Match each equation with the graph of f, g, h, or k. A larger base is closer to the y-axis when our base is greater than 1. A larger base is farther from the y-axis when our base is between 0 and 1. Let's look at A and C first. Select the graph for y equals 4 to the x, and then select the graph for y equals 8 to the x. The larger base is closer to the y-axis. I have 4 to the x, so that's going to give me g compared to h, because 8, the base, is closer to the y-axis. Now let's look at B and D. Select the graph for y equals 0.4 to the x. Select the graph for y equals 1/5 x. That's the same thing as 0.2 to the x. A larger base is farther from the y-axis. So which is bigger, 0.4 or 0.2? Yep, 0.4 is farther from the y-axis, so that's going to be k. And then D, of course, is f. Solve the equation for x. 2 to the 6x minus x squared equals 2 to the 8. Our bases are the same, so we can make their exponents equal to each other. We have an x squared, so we know we're going to have to factor. And to factor, we need x squared positive. So I'm going to add x squared to both sides, and then subtract 6x from both sides. This gives us 0 equals x squared minus 6x plus 8, perfect to factor. Now all we need to do is think of two numbers that multiply to 8 that add to negative 6. Negative 4 times negative 2 is 8, and negative 4 plus negative 2 is negative 6. If this one sounds familiar, it should. We factored this one just a second ago, and we ended up with x minus 4 times x minus 2. We make everything with an x equal to 0, so we'll have x minus 4 equals 0, and x minus 2 equals 0. We add 4, and we get x equals 4 as one of our answers. We add 2, and x equals 2 is our other answer. So 2 and 4 are our solutions. Practice, practice, practice. That's the best advice I can give you. Did you like it, the video? Well, like it. Did you really like the video? Why don't you subscribe? Did it help you? Why don't you share it with a friend? Remember, it's not magic, it's math.